Determine whether each relation is a function. Number one, I have a mapping diagram. Is this a function?
Yes.
Why?
Because the numbers are the same.
Because there are no repeating x values. Is the easiest way to look at whether something is a function or not. Good. How about number two?
No. There are two. No. You're missing the third one. Otherwise it would be a function.
Because in my domain, I have two sixes. Remember, domain is my x values.
Why is it the 3 6?
Number three, is it a function?
No. Because there are two.
Esco, why not?
No.
Yep, good. My x, I have x values of 2 twice. That means I have different outputs. Doesn't have exactly one output. It has two of them. How about number 5?
No.
What do we use to determine
The dots. A straight edge.
a straight edge? Vertical line test. You're going to hear this again in your future.
We're both on the 0 axis.
Correct. On the y-axis, I have 2 points that are on the same vertical line. This is not a function.
Number 6 and 7 are both yes.
Yep, vertical line tests. Can't get any easier than this. Number 6 is a function. It only intersects at one point. Same with number 7. It only intersects at one point. Now remember, these kind of curve, they keep curving slightly up and curving slightly down. So they're not on a vertical line, so it is a function.
That means later in that day.
This is easy points on quiz. What about number 8?
No.
No.
I mean, it's real easy to see that that is not going to be a function.
That looks like rocket bombs.
Now, this is where a lot of you have a little bit of trouble with. Evaluating functions. This says it wants to find the f of -3. So first of all, we're going to have to use the f function, which is f of x equals 6x plus 7. Now remember, this function notation is just telling me, hey, your x value is your x value is -3. Okay? So wherever you use the f function, because of the f, wherever you see an x, you plug in -3. So I have the f of -3 equals 6 times -3 plus 7. Okay, 6 times -3 is -18. Yes, you have to. Okay, if you can simplify it, simplify it. So the f of -3 equals -11. What about the f of r minus 2? Dewey, help me out here. What's the f of r minus 2? What does it equal? Remember, I have to use the f function, so what do I start with here? 6, good. Instead of x, I'm going to substitute in what? R minus 2. Okay, and what else do I have, Dewey? What else? Plus 7, okay? Now, you should be able to, in Algebra 1, you should be able to simplify this.
Really?
Okay.
Are you sure? 'Cause I mean, some of them.
Yeah, all you have to do here is distribute the 6 and then combine like terms. So 6 times r is 6r. 6 times -2, -12, and then we have the +7. Combine your like terms here. So the f of r minus 2 equals 6r. What's -12 plus 7? Good. There's my answer. Thank you, Dewey. How about number 15? Now be careful because we got to, first of all, we got to use which function? The g function, which is x squared minus 4. So let's rewrite that. The g of x is x squared minus 4. So the problem tells us, now be careful, this is a little tricky. Okay? So the problem tells us wherever we see an x, no, we're not going to do composites. We're not going to do that in Algebra 1. Okay, so it's telling me wherever I see an x, I'm going to put an a, and then when I'm done with that, I'm going to add 9 to it as my last step. Okay, so first of all, wherever I see an x, I'm going to put an a. So the g of a equals a squared minus 4. So I did that part, and then I'm going to add 9 to the rest of it. Add 9 as the last part. So what's -4 plus 9? So I have the g of a, and then I'm adding 9, equals a squared plus 5. Okay. It's a little tricky. Yes, Esco. Because they're telling me wherever I see an x, replace your x with a. This is kind of the beginnings of function and function notation. Algebra 2, you're going to be working with this quite a bit. Pardon me? Yep. It is actually easy, but at the same time, if you got to be careful about details, you know. How about 19? So I have the g of -b. So I go back to my g function. I plugged in -b for my x here equals -b squared. So I'm going to put -b squared. Put that in, always put negative numbers when you're raising it to a power. Make sure you put negative numbers in parentheses. And then I have the -4. And that one's actually a lot easier than the one before it. Yeah, that's it.
Why did it jump from 15 to 19?
I have unlike terms. Huh?
You jumped from problem 15 to problem 19.
Yeah. It's because I took these out of the book.
Unlike terms, so it stays like that.
He could have edited on a separate page.
It's too much work.
Why?
Because there's a lot of cut and pasting and stuff involved.
Oh.
And I can't go from, I have to,
Another teacher gave it
I have to do like 3 software packages. I just can't go from. I can't cut it from the book and paste it to a Word. I can't do that. I have to go to Notebook, put it in Word. All right, number 1. It says find the rate of change represented in the table or graph. What's rate of change?
No one knows. I can tell you this.
Rate of change is just slope. Yep.
It's gonna be 4 over 3.
Okay, slope. Now, we want to... God, you guys are so immature. Okay, the difference between rate of change and slope. Rate of change, we like to have 1 unit in the denominator. Okay? So what we're going to do is we're going to find the slope, and then we're going to actually divide it out. Okay? So I have my 2 points here. If you have a graph, now we could do this algebraically, right?
Yes, we could.
Slope equals y2 minus y1 over x2 minus x1, which is just a detailed way of saying the change of y over the change of x. You're going to see this again and again and again, okay, especially in 2 years. We could do it algebraically. We could call this x1, y1, x2, y2, but what's easier when we have a graph?
Just count.
Just count. It's rise over run, right? Okay, so we're going to go up or down first. You could go from this point to this point and this point to that point. Doesn't matter. Okay, so let's go up. 1, 2, 3, 4. So we're going to go up 4. And to the right, 1, 2, 3. So there's my slope. Okay. Rate of change, we normally like to just multiply it out. So we're going to get a decimal in our numerator. And actually, it's going to become our whole number because we put it over 1. Okay, so we're going to take 4 divided by 3. Now, if they were asking for slope, if they were asking for slope, we're done. Okay, because we always leave slope in fraction. Rate of change, we actually divide it out. I get 1.3 repeating. 1.3 repeating. Okay, usually with rate of change, it works with real life problems, and we have labels attached to it. That's why we normally have it as a whole number. 1.3 repeating is technically our whole number. All right, what about rate of change in our table here? How am I going to find slope in this table? I don't have a choice. I don't have a graph unless you want to make a graph and very accurately, and that would take a long time. So I'm going to have to do this algebraically. I'm going to pick 2 points. Okay. You could do that, but it's going to be just a little bit easier if we don't deal with negative numbers, right? Okay. So this is my x1. Y1. This will be my x2, y2. And I'm just going to plug it in my formula. Okay? Y2, 10, minus my y1 is 2, over my x2, 7, minus x1, 5. So I get 8 over 2. And the rate of change is 4. Works out nice. Everybody should get a really good grade on this. This is not that hard of a quiz. The hardest part is function notation.
What's that? Oh, this.
Okay, number 3. Refer to the graph at right. This is, again, the rate of change.
It's 0.56.
And they want it from 2002 to 2004.
0.56.
And actually, that's my x value, right? Okay, so my rate of change for the x value, so remember, it's change of y over the change of x. My change in x is what? 2002 to 2004. What's my rate? What am I changing? How much? 2, right? You should be able to do that in your head. Okay, the rate you're changing 2 years for my x, 2002 to 2004.
Oh.
Okay, now in 2004, our y was, just follow the graph, 22.88 minus my 2002 y value is 18.87. Okay, so all I have to do is put all that in the calculator. Let's see, 22.88 minus 18.87 equals, please put enter before you divide it by 2. So it's going to be approximately 2. Okay? Well, what does that 2 mean? Well, it means that the price between 2002 and 2004 rose about, what is it, $2? 2020. It just says price in dollars, so $2. Okay, so that's what it means. It means from it raised, the price rose $2 in 2 years. Okay, that's what that means. Now it's on C. It's asking, well, look at the graph, and without doing all the computation, use an educated guess. Use your common sense. Where do you think it's going to be a higher increase between the years? Look at the graph. Where is it going to have a higher increase than $2? Okay, here I am currently.
Oh, wait, I just divided.
Here's my rise of $2, right? My rate is $2. Where is it going to be a steeper rate? Just look at the graph. Yeah, this line right here. That's a steeper rate increase between 98 and 2000. Look on your own paper. Okay, so between which years? 1998 to 2000. Okay, so some of these problems are asking you to actually use your brain a little bit, instead of just plugging in numbers and computing, like the next 6 problems. You're just putting those into the formula and computing, right? X1, Y1, X2, Y2. So my slope equals Y2 minus Y1 over X2 minus Y1, X1. 3 minus 0 is 3. Negative 4 minus 8 is negative 12. Always reduce your fraction. What's the easiest way for you guys to reduce fractions? That's right, put it in your calculators. Let's see, I've got 3 divided by negative 12. Hit enter. Math. Enter. Enter. I get negative 1/4. Your quiz isn't that much longer than what's here. 105.